Good morning, fourth grade. This morning we're going to talk about area and perimeter, and you might be wondering why we're looking at my carpet, which maybe I should have vacuumed before this video, or maybe why we're looking at the tile on my floor. The reason we're looking at the tile on my floor and my carpet is because when we're talking about area, I want you to understand why we care about area. And to understand that, I want you to think about things like tiles. And I happen to have 3 cool tiles here. If I wanted to change the tile on my floor, let's say I was tired of this tile here and I found these fancy tiles, I would have to know how many of these fancy tiles I would have to use to cover my entire kitchen floor. Now, as you can see, these fancy tiles are a totally different shape than my tile on my floor, and they're a different measurement as well. I'm going to say that these are probably about a 3-inch by 3-inch tile, as opposed to the tile on my floor that looks like it's about a 12-inch by 12-inch tile, or this is a squared foot, right? 1 foot by 1 foot by 1 foot. And so this morning, we're going to come over here to my math board. We're going to think about area, and we're going to think about how to calculate area, and we're going to think about how to calculate area when we have combined shapes. And this is from our black and white page 13.3, and this is specifically problem number 2. So let's take a look. We know that to calculate area, we need to know the length times the width, or we could also say the width times the length. The commutative property doesn't care. We need to know this one side, maybe the length times this side here. And inside this rectangle, I've drawn some squares to kind of show you that when we're calculating the area, we care about the squares, how many squares we need to finish that, which is why when we write our answer, our area is going to be some number, and then we're going to put SQ for squared, and then we'll put the measurement we're using, and in this case it's feet. FT means feet. So we know our area, A, is going to equal some number square feet. And don't forget the square, that's very important. Now, you'll notice over here I have a P equals. This is a reminder about perimeter. Perimeter is the distance around a shape. And in the case of this combined rectangle, if I wanted to know the perimeter, that would be pretty easy because I have the lengths of each side, and I could simply add all the sides together. But this morning, I actually want to know the inside space, and that's a little bit trickier. So there's something I have to remember about rectangles. I have to remember that rectangles are 2 sets of equal sides. And to be able to solve this problem, I'm going to go ahead and think of this shape as 2 rectangles instead of one kind of big weird shape. And I need to make the decision to draw a line somewhere, and I'm going to draw a line right here. Now, some of you may have already solved this problem and you drew a line right here, and that would be equally correct. But for the sake of today's video, I'm going to draw a line right here. And now I have 2 shapes. I have a rectangle right here, and then I also have a rectangle right here, which looks like potentially we could also say that it's a square, but we'll have to find out. Now, remembering that area is length times width, when I look over here at this rectangle, I know the length. I know this side is 12 feet, and I know that this little piece here is 9 feet. So I already know everything I need to know to calculate the area of that shape. But this shape is a little trickier. So let's take a look at what we do know about this shape. We know that this length is 7 feet, okay? And I know that this little space in between here is 5 feet. And in case you haven't noticed, 5 plus 7 is 12 feet. So I know the length here and here, and these lengths are the same as this length over here. So in that case, if this is 7 feet, well then I know that this guy right here is also 7 feet, right? Because it's a rectangle and these 2 sides are going to match. I also know that this is not a square because this guy up here is 5 feet. And if this was a square, this would be 5 feet by 5 feet by 5 feet by 5 feet. Now, let's take a look down here at the bottom. I've got to figure out this length right here. but I have some helpful information. If I look at the top, I see that this is 9 feet and that this is 5 feet. And if I was to add 9 feet plus 5 feet, I would have 14 feet. Because I chose to draw my line right here, it is safe to assume then that this little length right here is 5 feet. Woo! I have everything I need to solve the area of this mixed rectangle. The first thing I'm going to do is I'm going to multiply my length times my width. And in this case, that means my area is going to be 12 times 9. Now, those of you who know your 12's facts, you have already thought of the answer. Those of you who do not, maybe you thought, well, I know that 9 times 10 is 90, and 9 times 2 is 18, and 90 plus 18 is 108. And in this case, it's 108 square feet. Great. That's only the area of this large rectangle here. Now I've got to look next door. Here I have 5 feet by 7 feet. So my area is going to be 5 times 7. And hopefully all of you did that math quickly in your head. And you said, Mrs. Lewis, that's 35 square feet. Am I done? No. This is the part where you tell me, no, Mrs. Lewis, you're not done because you need the area of the combined rectangle, which means my last step is to add this area plus this area so I know the total inside space of this combined shape. So I'm going to do a little addition over here. I have 108 square feet plus 35 square feet. I know that 8 plus 5 is 13. I carry my 1. My answer is 143 what? Squared feet. And I'm going to put my 143 right here. My area, my inside space is 143 square feet. I figured that out by taking this large combined rectangle, breaking it into 2 different rectangles, solving the area for each rectangle, and then adding those areas back together to get my answer. Welcome back, 4th graders. I miss you. Here we are. I'm getting ready to teach you 13.4, but first I'd like you to take a look where I'm sitting. That is my front yard, and it is a beautiful day, and I hope you all got a chance to go outside and enjoy the day. I'm out on my front porch right now, and I'm getting ready to teach you lesson 13.4, and for those of you who already braved this lesson, awesome. You can check your work after watching this video. For those of you who haven't attempted it yet, have no fear, I'm here to help. Now, I am focused on this page, and off the screen you can't see me, but I'm drawing a kind of a rectangle. You know, guys, you know how I like to do approximate rectangles. And I'm looking at number 2, so I'm getting ready to switch over. I'm looking at number 2, and I see that in this lesson they want you to do a few things. They'd like you to find either the perimeter or the area, but they give you only a little tiny bit of information. And so over here I'm starting to draw number 2. And number 2, they have this rectangle, and they say, hey, this side is 9 meters, and then that's all we're going to tell you. And they want you to find the perimeter. Well, actually, excuse me, they tell you the perimeter. It's 42 meters. Then they want you to know the length. So we'll call that L, which is for the length. So they say, hey, we're going to tell you this is 9 meters, but we want to know what this side is. And so the question is, do we have enough information to solve this problem? And the good news is yes, we have all the information we need to solve this problem, but we need to think back to something that we know about rectangles. And one really important thing we know about rectangles is that they are 2 sets of sides that are the same. And if this is bothering you, it's starting to bother me. I feel like I should make this a little more square. There we go. This side being 9 meters means that this side is also 9 meters. And now that I know that, I have to think about what I know about perimeter. When I'm finding the perimeter, I'm finding the outside space. I'm finding the outside length to be specific. So for example, when we look at my yard, my garden down there, you can see that there's a fence. And when my husband and I had to fix that fence last spring, we had to measure the perimeter, the outside length of our garden. It's a pretty big area. So we had to measure how long the fence was on that one side, and then way over there, so we had to do the length and then the width, and then we had to figure out all four sides so we could enclose our garden so the deer wouldn't eat everything. And in our little rectangle here, I've got 9 meters and 9 meters, and I know my total is going to be 42. So to find the perimeter, I need to add the length of all of the sides. And in this case, I know that I have two sides that are 9 meters. So far I have 18 meters. I also know that my total perimeter is 42 meters. So the thing I need to do is I need to find that difference. I need to find the leftover meters so I can figure out what each of these sides is. So I'm going to take 42, that's the number that was given to me, that's my total perimeter. I'm going to subtract the 18 meters that I know that I have with the 9 plus the 9. And so, I can't take 8 from 2. I'm going to borrow from that 4 and make it a 3. I'll bring my 1 over here in front of my 2. And now if I subtract 8 from 12, I know that I have 4. I'm going to come over here and take 1 from that 3, and now I have 2. And I have 24 meters left over. Now, that still doesn't really answer my question because I have 24 meters left over for these two sides, which means to figure out this one side, which is what they want me to do, to figure out this length, right, which is just the length on this one side, I need to take that 24 meters and I need to divide it by 2 because I have two sides. And hopefully most of you have done this in your head now and you've said, well, 24 divided by 2 is 12, and that's 12 meters. And I know that my length is 12 meters. And I could go ahead and label each of these sides. And that would be my answer to number 2 on lesson 13.4. I'm back and I'm still on 13.4. For those of you who watched the last video when I solved number 2, good news, I'm going to do number 3 and maybe even number 4 right now, just to help you out. Let's take a look at number 3 again. Number 3 is assuming that you know a few things about rectangles, and the thing that it most assumes is that you understand that rectangles have two sets of sides that are the same. And on number 3, they don't want you to solve for the perimeter. Instead, they want you to figure out the height, right? And to figure out the height, if we said that this h is height and that this here, this 4 is the width, they give you the area. And so what I need to know is I need to remember how to solve for area. Unlike perimeter, when I add the lengths of the sides, with area, I'm actually going to multiply my height times my width, or my length times my width. So we could say that's length times width, or height times width. They are exactly the same thing. But either way, I have only one number. I have this 4 centimeters here. And so I know it's going to be 4 centimeters times some mystery number equals 28. Now, those of you who know your math facts, fantastic. This is going to be an easy problem. You know it's 4 times some number is 28. Those of you who are still working on math facts, you might be doing something like this. You might say, well, it's 4 plus 4 plus 4 plus 4 plus 4. And you're going to count your 4s until you get to 28. You could also use long division, but ultimately what you're going to find is that you are going to need 1, 2, 3, 4, 5, 6, 7 4s, because 4 times 7 is 28. And that's going to be our answer. By the way, I did forget to include that this is squared centimeters. It's really important when you're writing the area to include this, that this is a squared measurement, because when we're talking about area, we're imagining like a bunch of little tiny squares on the inside. And that is number 3. Let's move over to number 4. Number 4, we'll pretend like I have enough room on my board for number 4. Number 4 gives us one side. It gives us 25 inches. And I'm going to go ahead and fill in what I know is that this other side is also going to be 25 inches. And then it says that my area is 200 square inches. Wow. Now, the fact that I filled this in over here doesn't really affect or actually even benefit me in solving for this other side, but nonetheless it's nice to know. If I wanted to figure out my perimeter, I could figure it out that way with this information, but I want to know my base. And so by base they mean, you know, like the width, however you want to think of this as base or width. Either way, they want to know what this side is. So really all I need, the only information I need is this 25 inches here. And I need to think 25 times what number is 200. The good news is we've been working with money. So I want you to think about how many quarters, because quarters are 25 cents, it takes to get to $2. And oh, my cat has just joined us. This is Yoda. Hello, Yoda. Nice to see you. Joining us for the math lesson. She's very curious about this. And what you're going to find is if you add 25 plus 25 plus 25 plus 25 plus, let's say, 4 more 25s, your answer is going to be 8. And so 8 times 25 is going to equal 200, and that is going to be your answer. And by the way, that's 8 inches because we have inches here. Don't forget to label. And 8 is your base. I hope that was very helpful. There's Yoda, and I'll see you next time. Here we are again, and now I am looking at lesson 13.5. And again, some of you have probably already worked on this, and some of you may just be beginning, and I'm hoping that this will be very helpful. I'm looking at number 2 here, and I've actually drawn it out over here on my board, number 2, and I'd like to read you the problem. It says a rectangular wall has a square window. So here's my rectangular wall, and here's my square window as shown in the diagram. What is the area of the wall not including the window? So let's say I wanted to make this really fancy and put some really cool wallpaper on the inside of my living room wall, but obviously I don't need wallpaper for the window. I won't be able to see through it anymore. And so I need to figure out the area excluding this inside space. And while this might look like a complicated problem, you have all of the skills that you need. The first thing you need to do is calculate the area of the larger rectangle. And remembering that area is going to be my length times my width. Let's say my area is 8 times 14, and I will add back my units of measurement, but for the sake of easy mathematics, I'm just going to put 8 times 14 at this moment. Now, those of you again who know your math facts, I'm not sure you all know your 14s, and so when I look at a problem like this, I think, well, I do know that 8 times 10 is 80, and I could even put that up here, 80, and I know that 8 times 4 is 32. And when I solve it that way, I know that 8 times 14 is 112. And that makes my life pretty easy. And I like that. Now I'm going to go ahead and label this square feet so I have my answer written correctly. And then I'm going to take a look at this little inside window. And this little inside window happens to be a square. It's 4 feet by 4 feet. And then I know it's 4 feet by 4 feet. But in this case, I'm just going to multiply this length times this width, or width times length, excuse me. And 4 times 4 is 16 square feet. So now I have 16 square feet over here. I have 112 square feet over here. And I have one thing left I have to do. I have to take this square footage away from my total square footage because I don't need fancy wallpaper for that window. So I'm going to go ahead and go over here and I'm going to do a little bit of subtraction. I'm going to take 112 And I'm going to go ahead and, sorry for the moving of the board, and I'm going to go ahead and subtract 16. And when I do that, I discover, oh no, I can't take 6 from 2. I'm going to borrow this 10, which makes it a 0. I'm not going to panic about that yet. I'm going to bring this 10 over here. Now I have 12 ones. I'm taking 6 from the 12. I get 6. Then I come over here. Oh no, I have a 0. Nothing to fear. I'm going to basically make some change. I'm getting rid of this 1, this 100, and I'm making 10 more 10s. I'll take 1 away, and I have 96 as my answer. 96 what? 96 square feet. That's how much fancy wallpaper I need for this new room. That was number 2 for 13.5. I hope that was very helpful.